Ancient rock births life, not fossil fuels, phosphorus. And we are running out of it. This is not a projection from a fringe think tank. It is the consensus of geologists, food security researchers, and agronomists who study exactly one question. How do we feed 8 billion people when the mineral that makes it possible is finite, non-renewable, has no substitute, and is increasingly concentrated in the hands of one nation that most of the world knows almost nothing about? There is no recycling phosphorus from thin air. There is no synthetic replacement. There is no technological workaround waiting in a lab. When the accessible deposits of rock phosphate are gone, the era of modern industrial agriculture, the era that took human caloric intake from chronic scarcity to relative abundance, ends. And what comes after it will not look like anything we are prepared for. Here's what makes this more unsettling than almost any other resource crisis on the planet. Nobody is talking about it. Every atom of phosphorus on Earth was forged in the cores of dying stars billions of years ago, and scattered through the cosmos before our solar system even existed. It cannot be manufactured. It cannot be synthesized. What is here is what there is. And we are burning through it at a rate that would have been considered civilizational suicide by any previous generation, except previous generations didn't know what they were doing. And we do. To understand why phosphorus is the element everything depends on, you need to understand what it actually does. Every living cell requires phosphorus. It is the backbone of DNA, ATP, life's energy currency. Plants cannot grow without it. Animals cannot exist without it. There is no workaround. There is no version of complex life that does not need this element. Manure, waste, rotation-fed soil's phosphorus, and the slow grinding of mineral-rich rock into farmland over centuries. Yields were modest. Famines were common. Populations were limited by what the land could naturally sustain. Then came the 20th century, and everything changed. In the early 1900s, scientists discovered that you could crush certain phosphate-rich rocks, treat them with sulfuric acid, and produce a water-soluble fertilizer that plants could absorb immediately and in massive quantities. Combined with nitrogen fertilizers and improved seed varieties, this became the engine of the Green Revolution, the agricultural transformation that, between 1950 and 2000, doubled and then tripled global food production while the world's population did the same. Today, modern agriculture consumes approximately 50 million tons of phosphate fertilizer every single year. Without it, global crop yields would collapse by an estimated 40 to 50%. Roughly half the food currently grown on Earth would not exist. And roughly half the people currently alive, somewhere between 3 and 4 billion human beings, would not have enough to eat. That is the scale of the dependency we have built. Now here is the part where the story gets genuinely frightening. Rock phosphate is not evenly distributed across the planet. It was deposited hundreds of millions of years ago in specific geological formations, mostly ancient seabeds where marine organisms accumulated over eons and compressed into phosphate-rich sedimentary rock. These deposits exist in relatively few places, and the economically viable, accessible deposits, the ones that can actually be mined and processed at a scale that matters, are fewer still. For decades, the United States was the world's dominant phosphate producer. Florida and North Carolina sat atop vast reserves. American farmers never had to worry. U.S. reserves dwindle. Imports now vital. Its own deposits are declining in both quantity and quality. China guards its future, restricting exports. Russia has deposits. Jordan has some. A few others. But none of this compares to Morocco. Specifically, Morocco and the territory it occupies by force, Western Sahara, a region whose legal status remains one of the most unresolved territorial disputes on the planet, whose indigenous Sahrawi people have been living in refugee camps in the Algerian desert for nearly 50 years, and whose phosphate wealth has been mined and exported without their consent since Morocco invaded and annexed it in 1975. The numbers are almost incomprehensible. Morocco and Western Sahara together hold an estimated 70% of all known remaining phosphate rock reserves on Earth. Some estimates put it higher. The United States Geological Survey, which tracks global mineral resources, has acknowledged that Morocco holds reserves so dominant that no other country is even remotely comparable. The next largest holder, China, has roughly 6%. Everyone else combined has less than 25%. This is not like oil, where dozens of countries hold significant reserves and geopolitical risk is spread across multiple regions and alliances. This is a single nation, a monarchy with a complicated human rights record, a disputed territorial claim that the United Nations has repeatedly called illegal, and a state-owned mining company called OCP Group that operates the largest phosphate export operation in the world, sitting atop the mineral foundation of global food security. And the world has largely chosen not to notice. OCP Group, the Office Chérifien des Phosphates, is one of the most powerful companies most people have never heard of. It is wholly owned by the Moroccan state, mines phosphate from Morocco and Sahara's rich deposits. Deep in the occupied territory, processes it into fertilizer and phosphate rock, and exports it to buyers across the globe. It supplies a significant portion of the fertilizer used in India, Brazil, sub-Saharan Africa, and large parts of Europe. When OCP changes its prices, farmers on 5 continents feel it. Morocco's quotas shift global food prices, a silent choke point, more consequential than oil's halt. Now, when does the rock run out? This is where the science gets genuinely contested and genuinely alarming. The concept of peak phosphorus, the point at which global production reaches its maximum and begins to decline, has been debated intensely since a landmark 2009 paper in the journal Global Environmental Change projected that peak production could arrive as early as 2033. That specific timeline has been revised, debated, and updated. Some researchers argue that known reserves could last another 300 years at current consumption rates. Ore quality dips, costs rise, demand soars, deposits scatter. Argue the effective crisis window is much shorter and already underway. What is not contested is this: phosphorus is finite. The richest, most accessible deposits have already been mined. What remains is increasingly deep, increasingly contaminated with cadmium and other heavy metals, increasingly expensive to extract and process. And global demand is not declining. It is rising as populations grow, as diets in the developing world shift toward more meat and dairy, which require dramatically more fertilizer per calorie produced, and as agricultural land is pushed to higher and higher yields to feed more people from roughly the same amount of arable land. Phosphorus waste. A hidden dire crisis. Of all the phosphorus that is mined, processed into fertilizer, and applied to agricultural land, only a fraction reaches the food that humans actually eat. A significant portion washes off fields during rainfall and irrigation, flowing into rivers and lakes where it triggers massive algal blooms. The same phenomenon responsible for the dead zones in the Gulf of Mexico, the Baltic Sea, Lake Erie, and hundreds of other bodies of water. These blooms consume oxygen, kill fish, and render water bodies biologically dead. Phosphorus sinks, lost to fields. Recovering phosphorus from wastewater, from human sewage, from livestock manure, from food processing waste is technically possible and is being done at small scale in several countries. The Netherlands, Germany, and Japan have made significant investments in phosphorus recovery technology, but the global infrastructure for closing this loop barely exists. Humanity mines phosphate from ancient rock, applies much of it to fields, watches a large proportion wash into waterways, and then mines more ancient rock to replace it. This is not a sustainable cycle. It is the definition of a one-way depletion. The geopolitical implications of all of this have begun to register, quietly, in the strategic planning of major powers. China moved years ago to restrict phosphate exports, classifying it as a strategic mineral. India, which imports nearly all of its phosphate fertilizer and applies it to feed a population of 1.4 billion people, has identified phosphate security as a national concern. Brazil, whose enormous agricultural sector feeds much of the world, is acutely aware that it imports the majority of the fertilizer that makes its farmland productive. The European Union, following the supply chain shocks of the early 2020s and the disruptions caused by the war in Ukraine, which also affected fertilizer exports from Russia and Belarus, has placed phosphorus on its list of critical raw materials. But none of this has translated into the kind of public conversation the scale of the problem demands. Phosphorus remains a policy footnote, a concern for specialists, a word most people associate with high school chemistry rather than existential risk. And yet here is the arithmetic that does not go away. There are 8 billion people on this planet. That number will reach approximately 10 billion by mid-century. Feeding those 10 billion people, as they grow wealthier and shift toward more resource-intensive diets, will require dramatically more food than we produce today from roughly the same amount of arable land, with a climate that is becoming increasingly hostile to agriculture, using a finite mineral resource whose most accessible deposits are concentrated in one nation and are being drawn down with no meaningful plan for what comes after. This is not a crisis that announces itself with a bang. It is a slow arithmetic of depletion and concentration, playing out beneath the surface of every meal eaten on this planet, largely invisible, almost entirely undiscussed at the level of global politics, and structurally resistant to the kind of short-term thinking that dominates both markets and governments. The element is irreplaceable, the deposits are finite, the dependency is total, the concentration of control is extreme, and the clock is running. The only question that remains is whether anyone with the power to act will choose to understand this before the answer becomes obvious in the worst possible way.
Thanks for watching Macro Explainer. Subscribe for more clear breakdowns.